talking this air.
Let's see how much you know.
Pretty close to the cover up.
Goes back to second. That's horrible.
Trig graphs. Graphing trigonometric functions. You get to answer. Okay, awesome. First volunteer. We're going to graph sine and cosine. And you already know that the sine is nothing more than the y of the xy coordinate, and cosine is the x of the xy coordinate on a unit circle, right? You totally get that. All right, so what we're going to graph is x is going to be the value of t, and y is going to be what we get when we take the sine of t. Okay, so t, if we say, is 0. And then what is after 0 degrees? We have 30 degrees, which is what? Pi over 6, right?
Yep.
Right, so as we travel around the circle, x is going to be the distance, or t, all the way around the circle. That's our x value. We're going to graph that relationship of t and the function of sine, okay? Or the sine function. Okay, and then we have pi over 4, then pi over 3, pi over 2. And we're going to go on all the way around the circle. So just for a visual purpose, for those of you who are still kind of struggling, I would suggest you learn the unit circle very quickly. You're going to have another quiz over the unit circle and also that chart. Okay? So most of you did extremely well in the unit circle, so that next time we do it, you guys will get another good grade for your quiz. The rest of you, figure it out. Do something. All right, so what is y when we are on the unit circle right here? That's me. If you want to answer these questions, what is y? One, right? No, it's not 1. What is the coordinate right here? 1, 0. What is the y value? 0. Don't listen to those ding-dongs. They're not here to help you. Okay, the y value is 0 when t is 0, okay? All right, now at pi over 6, we're at 30 degrees. What is the y value of that coordinate? 1/2. It is the short side of this triangle. It's 1/2. Pi over 4 is 45 degrees. What is the y value of 45? Radical 2 over 2. You don't have your calculators ready, you're going to have to tell me what that value actually is. And then 60 degrees, or pi over 3, it is the long leg, which is radical 3 over 2. Everybody ought to be able to do this very quickly. What is the y value right there? 1. All right, we'll stop right there for the moment, but we're going to go all the way around the circle. Okay? So if we're going to graph this, this is an xy graph. Okay? So x, this is y. Put 1 here and put -1 there. And we're going to deal with the first and second quadrant here, first and fourth quadrant. We're going to graph what the sine function looks like as we go around the unit circle. So as t progresses from 0 to 2 pi, what is happening to the sine function? So the sine of y, what is happening here? So when x is 0, y is 0. When x is pi over 6, what is y? 1/2. So these are coordinates. At pi over 6, we're at 1/2. When we are at 45 degrees, or pi over 4, y is the square root of 2 over 2, which is how big is that? 0.7. Okay. When we are at pi over 3, we're at the square root of 3 over 2, which is? The square root of 3 over 2. On the calculators. So I need to look at everybody's calculator as you're sitting there staring at me.
0.86.
Square root of 3 over 2. 0.86.
I
We'll call it 0.9 for now. And then we're at pi over 2 at 90 degrees. Y is 1. So this looks like this. Close enough. Okay? And we're going to go until this repeats. What happens after pi over 2? Boom. 120 degrees. What is the y coordinate? Well, first of all, what is that in terms of pi? The unit circle. 2 pi over 3. Okay, so what is y at 2 pi over 3? Now you know why you need to know the unit circle really well. It's the long side. What is the y value?
1/2.
Radical 3 over 2.
Or not.
If you don't know this well, then I suggest you do a lot of work tonight. Because this isn't going away. The fact that I drew it up there should have been good enough to realize that it's the long leg. Okay? So 0.8, we're at 2 pi over 3. It's coming back down now. What's next? 45-degree reference point. What is this t value? I'm starting to wonder if you really did really well on the unit circle or you just memorized it for the second. You got to know how to find this stuff. Alright, so yes, radical 2 over 2, which is 0.7. So 3 pi over 4, 0.7. And then, thank you, 5 pi over 6, which is 1/2. Thank you very much. And then we are at pi. What is the y value at pi? This coordinate right here, what is that coordinate? Thank you. Maybe 1, 0, the y value is 0. So when we get to pi, we're 0. Now you're not going to have to do this for all these today. I'm just using this one to show you what it really looks like, and then you're just going to have to trust me after this, okay? So let's go on. 210 degrees.
7 pi over 6.
Thank you. What is the y value there? Negative 1/2. All of a sudden, we're down here. Negative 1/2. 5 pi over 4. What's the y value? Everybody should realize it's a 45-degree angle. It's going to be the radical 2 over 2, except it's negative. Pretty good so far? Not too hard, is it?
Are you going all the way around the circle?
Yeah, when I said we're going all the way around the circle, that meant we're going all the way around the circle. 360 degrees.
See
When I
what you
said
did
it's
there?
360
See
degrees,
what you
I
did there?
usually mean the full circle.
Do that part. I don't have enough room on my paper.
Well, isn't the long line here at the bottom?
Everyone else is using the same
Love
size
space.
paper as she is.
We won't do this on all of them, okay? It's just for this one. Alright, so that's negative 0.7. So 5 pi over 4 down here. And then the next one, what is this? 4 pi over 3. Now you know why you did your chart, right? What is this y value? Which is negative 0.9. And then we have 3 pi over 2, which is, what's the y value?
Negative 1.
Negative 1. Alright, so it's starting to turn. I think you've got the rest of this figured out. But we're going to keep going. What's that pi value?
5 pi over 3.
which is what? Negative 29. And the next one? Which is, what's the y value? Good? And 11 pi over 6, thank you. Negative 1 half the y. And then we're back to 2 pi, which is 0. The sine function is a wave. That's the sine function. All right. That's the sine function. All right. From 1 to negative 1, this is your amplitude, which I'm going to explain here a little bit. This is the period of which it starts to repeat from 0 to 2 pi. So 2 pi is its period. In a minute, you'll understand that a little bit better. Okay, we're not going to do that again. So let's talk about what the cosine looks like. Again, t and that's your x, your y is going to be the cosine of t. We're not going to do all these. We're going to do 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are the only ones we're going to do on this graph. Okay? And then we'll just kind of connect the dots following this pattern that we've done here. So, at t being 0, what is the cosine? Cosine is just the x value of your coordinate. So when t is 0, what is the x coordinate there? The x coordinate is 1. At pi over 2, everybody watch. At pi over 2, what's the x coordinate there? 0. At pi, what's the x coordinate? Negative 1. At 3 pi over 2, what's the x coordinate? 0. And at 2 pi, we're back to 1. Alright, let's graph this. 0, 1. We're going all the way to 2 pi, so we'll put 2 pi right here. Split it in half, that's pi. Split that in half, that's pi over 2. And that in half, that's 3 pi over 2. Our points are at 0, 1, 0, negative 1, 0, and 1 again. The cosine is a wave just like the sine, except it starts up here and goes down, back up, and over. It is identical to this except it's shifted. Okay? The sine at 0 is 0, the cosine at 0 is 1. It's still a wave as it keeps going. This is what you need to remember. This is what the sine looks like. That's what the cosine looks like. Any questions? If you want to know all the other stuff in between, you now know how to do it. Except that's the easy stuff. Alright? Transformations. Remember H and K? So this is a little bit like that. It's a little different, but we're dealing with how it shifts, how it shrinks, how it moves, okay? Alright, so here's the basic part. Y equals A times the sine of kx. A times the sine of kx. A is what we call the amplitude. It is the vertical shrink or stretch. If it's negative, it flips it upside down. So before we talk about K, let's just talk about the amplitude. I'm going to use this picture here and this information here to kind of do a few pictures. So it's going to be a little messy over there. Alright, so let's do y equals 2 times the cosine of x. In this case, 2 times the cosine of t. If the cosine of t is 1, what's 2 times that? 2 times 0 is 0. Good. So it's just 2 times those values. Pretty simple, isn't it? Now graph that. When t is 0, we're at 2, so we're up here at 2. When t is pi over 2, we're at 0. When t is pi, we're at negative 2. When t is 3 pi over 2, we're back at 0. And when t is 2 pi, we're at 2. What happened? Stretched it vertically. Stretched it vertically, right? Okay. That's what amplitude is. Negative will flip it upside down. Got it? Alright. What if we did this? Y equals the cosine of 4x. I'll make a new chart here. X, 4x, and the cosine of 4x. X is the same thing as t. 0, pi over 6, pi over 4, and pi over 3, pi over 2, and so on. We're just going to graph these just to see what it looks like. 4 is in the K position. This represents the period, how long before it repeats itself. YouTube, last warning, and then you're out. Got it? It's time to grow up. The period is 2 pi over k, whatever is in that position. All these are 1s, cosine of 1t, the sine of 1t. Okay? And each of these periods went to 2 pi. The period was 2 pi, because 2 pi over 1 is 2 pi. In this case, 2 pi over 4 is what? Pi over 2. So it goes all the way to pi over 2. Alright? What's 4 times pi over 6? 4 times 0 is 0. 4 times pi over 6? 4 times pi over 6? 2 pi over 3. Thank you. What's 4 times pi over 4? Pi. 4 times pi over 3? This is multiplying fractions, people. This is 4th grade. Multiplying fractions. 4 times pi over 2. It's 2 pi. Oh. Yeah, 2 pi. Alright. X is still these positions because the period has gone to pi over 2. So we're no longer going to 2 pi. We've crunched this all the way down. So the period is either going to stretch it horizontally or shrink it horizontally. Amplitude stretches vertically, either up or down, okay? So we need to make sure we got what x is. We're only going from 0 to pi over 2. So on this little graph over here, this normal cosine that we have here from 0 to 2 pi is going to be shrunk to fit in between 0 and pi over 2. It's going to look like this. But just to show you we're going to find out what these values are. So, what is the cosine at 0? What's the value of the cosine at 0? 1. What's the value of 2 pi over 3? 2 pi over 3. Where's 2 pi over 3? Where's 2 pi over 3? 120 degrees. This right here. The cosine of that, the x value. What did you say it was? Negative 1/2. The cosine at pi. Negative 1. The cosine of 4 pi over 3. Where's 4 pi over 3? 240 degrees. Okay? What's the cosine? This is what you need to visualize. 240 degrees. Right here. What's the x value here? Negative 1/2. And the cosine at 2 pi is 1. Alright, so we took all the way from 0 to 2 pi and we crushed it into just a 90-degree area. This was pi over 2 here. So we have pi over 6. We have pi over 4, which is halfway between 0 and 2, and pi over 2, and pi over 3. Alright, at 0, cosine of 0 is 1. Cosine of pi over 6 is negative 1/2. That's negative 1. Cosine of pi over 4 is going to be negative 1. Cosine of pi over 3 is negative 1/2. Cosine at pi over 2 is 1. So it goes down, goes back up, and over. So this is a curve. This just keeps going, by the way. That's what that looks like. But we're only looking at the period right here. This is just to show you how to come up with it. So, if you have something like this, you might want to make a chart like this. It's 4 times whatever we have for these values. 4 times each of these gives you this. Then you find the cosine or the sine of whatever that degree is. That's why you need to know your unit circle really well so you can graph this stuff. Alright, we're going to take 2 days to do this section. So we're going to stop with that before I give you more things to add to your trigonometric graphs, okay? Alright, page 396. I only want you to do the 3 to 27 odds. It's stuff just like this, okay? Alright.